Hello, students. So today I'm going to be recording the answer to this question right here. A stone thrown upward from a 100-foot building hits the ground in exactly 4 seconds. If its initial velocity is 86 feet per second, how far did it land from the base of the building? So this is a type 3 projectile question from your first unit, kinematics. And as you can see here, I've drew a picture for you. You should always draw a picture first when you do a physics question. First thing I did was I drew a sketch of the question. I got a 100-foot tall building. It doesn't need to be beautiful. I'm not an artist. You don't have to be either. Just draw a quick sketch. You can get your mind working on the problem already, okay? I know that it's being thrown at an angle because otherwise it would just land right back at the bottom where, straight up. If you threw it straight up, it would just land right back where it was. So there would be no distance from from the base of the building. So it has to be thrown at an angle. They did not tell us the angle, which might seem scary, but actually it's not that bad. We're still going to use the same two equations we always use for projectiles. Anytime you've got a projectile question, you're going to pretty much use these two equations here. The y equation, obviously, y is for the vertical direction, okay? So y equals yo plus voyt plus 1/2 ayt squared. Just as a quick, let's go over what each of those means. Y is the final position of the object. Yo is the original position of the object vertically. Voy is the initial vertical velocity of the object. T is the time that the object is in the air in this case. Ay is the vertical acceleration, which for most free-falling objects, for all free-falling objects, it would be negative 32 feet per second squared if you're talking about feet per second squared, like in America. But most of the time in physics, we use meters per second squared, which is negative 9.8 meters per second squared. But in this case, they gave us feet, so I'm using feet. I'm going to use 32 feet per second squared for gravity's acceleration. And that's always going to be straight down towards the Earth. So in this case, that would be negative because they're throwing it up. You need to make sure that you make the initial velocity positive and the acceleration negative. Otherwise, it will not be correct when you solve it. And of course, the final t is also time. So I plug in my numbers that they gave us. I know that it's landing on the ground, so the final height is 0. The starting position is 100 feet high. The vertical velocity, to get that, you got to do a little bit of trigonometry, but don't be scared. It's nothing crazy. We're just doing SOHCAHTOA here. So sine of the angle that it's thrown up at from the horizontal. Sine of that angle, if you look at this triangle down here in the bottom left that I drew for you, sine of that angle times the hypotenuse will give us the opposite side. So 86 sine theta is my vertical velocity. 86 cosine theta is the horizontal velocity. So I plug in the numbers. I do some algebra that you can see here. I solve for theta. Okay, so I'm not going to go through every single step here because you can see it and I don't have a lot of time. But theta, you get that the angle is 27 degrees. Okay, and you're just doing some algebra here. So it's not physics here. This is just algebra at this point. We've already done the physics part where we understood the equation, we drew the picture, we plugged in the numbers. Anyway, we get an angle of 27 degrees. Now that we know the angle, now we're going to switch gears and we're going to go over to the horizontal direction, okay? With projectiles, you always want to break it up into vertical stuff and horizontal stuff and try to keep them separate. But certain things are the same in both equations. For example, the time is the same in both equations and the angle is the same in both equations, okay? So you can see in our horizontal equation, x is the horizontal position, vx is the horizontal velocity, and for projectiles, horizontal velocity should be a constant because there's no horizontal acceleration, okay? So I plug in 86 cosine theta times 4, because 4 is the time, 86 cosine theta is the horizontal velocity, and then now that I actually know the angle is 27, I can plug in the angle for theta. So I get 344 times cosine 27. I put that in my calculator, and I get 306.6 feet. Now, some students are afraid of cosine and sine. Don't be. It's just a button on your calculator like multiplication. Just type in cosine 27. You plug it in. You push enter. Okay? And then you're going to multiply that thing, whatever it is. Whoops, there we go. That thing by 306.6. Anyway, by 344, and you get the answer of 306.6 feet for this question. All right, thank you. I hope that helped answer your question. Feel free to send me a message if you're confused still, okay? Have a great day.